Okay, welcome everyone to our module ICT Design Selection and Implementation. I believe we have two groups here. You're almost welcome, and I hope we shall have a fruitful session for today and the entire module. For most, I believe I have met one group already, the 2024 intake. The rest have not yet met me. Eric and group, have I met you before?
Yes, you did.
Yes, you have. Okay, so think that
yes, you did.
Okay, that's good. I from the timetable I had, I think we're running until March. Trying to remember clearly.
It was March 21st, if I'm not mistaken.
March 21st. Okay.
Hmm.
In that time, at least I have to have one weekend with you physical at Rubaga. We shall see how we can work that one out. Most likely it may be, if I look at the time I have with you, this must most likely be in March, I think. Somewhere there in between. I hope we can have a physical. Welcome to Kampala. I'm based in, like most of you know, I'm based in Fort Portal, Kienjojo to be specific. But I'm hoping at least one weekend to come and have a physical session with you. Now, based on that, I think let us begin. We have begun the evening late. So let me share my screen. Is my screen visible to all?
Yes, we can see it.
Okay. So I believe you all know me, so it's not, this won't have too much of an introduction about myself, the lecturer, but let me get straight into the course unit itself. So we've all heard of the term systems thinking, yeah? We've all heard of that term, not so? Systems thinking or systems.
Yes, doctor.
Yeah, we also have several systems theories in that. This is what this module is trying to do, is to bring systems thinking in ICT design, selection, and implementation. Now, when we think about this, of course, come back to who we are training to be, specifically for this module, this program, ICT architecture. What are we thinking about? We immediately we may go back to, we will see terminologies that we saw previously. We saw in when we were doing our bachelor's degrees, those who have done IT or computer science, we shall see things like system development life cycle and so on and so forth. And this may be the idea that we have in mind. We may automatically drive our mindsets to what we did at undergraduate level. You know, where we sit down, people tell us, this is the problem I have, and so on and so forth. And more or less, it's in a small section, yes, that's what it may be. But in reality, we are now looking at this at a management level, or more at project level, project management level, should I say. This is not a course unit about project management per se, but it is introducing systems theory or systems thinking to how we could manage, how we could bring about improvements with improvements within our business processes, with the how we can do this in the most efficient way possible. Yeah, the most efficient way possible that we can do this. Now, as we get further, a bit further, we'll have an idea of what we are talking about. We want to understand and discuss ICT architecture, because now we are not really into system development the way we think about it at the O-level stage, where you're thinking about, oh, I'm going to build something web-based, or I'm going to build something using Java or things like that. No. We are now looking at the holistic picture as management. As ICT directors, as CIOs, we're looking at the holistic picture, the entire architecture of our systems or system. We're looking at it in that sense. We want, within this architecture, we look at things like our data architecture. What data do we need? Where does it start from? Where does it go? Where will it be transformed? Who will access it? Then the network architecture. What needs to be connected? So we're not looking at developing systems per se, although we're looking at design selection, but we're looking at the holistic picture as management. We're now the management of the ICT, not the techies, but management itself. So this is what we want to see in the holistic sense of things. In system selection, so you notice we use terms like system ICT design, selection, and implementation. So we may not necessarily be developing something in-house, or we might be buying something off the shelf, or requiring somebody else to develop it for us. But this does not take us out of the system development life cycle. It doesn't take us out of it. In actual sense, it now becomes part and parcel of it. Part and parcel of it. Okay? So we may think about, okay, we may, as ICT management, we are thinking in terms of, I'm working within an organization, I'm part of a corporate structure. And within this corporate structure, sorry, Gertrude, can you unmute? Thank you. So we are part of a corporate structure. And within this structure, certain needs have been identified. Certain, would say, can be very negative and say problems, or certain needs, certain requirements have come up. And because of that, we need to do an upgrade, or we need to do a completely new thing in terms of IT. So in terms of our life cycle, we may want to say, shall we build something in-house? Or shall we buy something? Try and move this to the side. Shall we buy something? That is a question that we, based on the needs and based on our strengths. As we carry out as we want to carry out this selection, what's the second thing we need to do as we are considering these options about getting this new solution for our problem, our needs? We need to benchmark. What are other people within our sector doing? And especially those who are doing best practice, those who we wish to be. Yeah. What are the underlying standards? What are the generally agreed upon standards that we need to follow as we go about selecting this new system or upgrading to this new system, then in terms of implementation, what strategy or approach are we going to take? Yeah. So that's what selection is involved with, the design and selection part of it. Then we come to ownership. Okay? Ownership. And this goes back to whether we are building versus buying. If we are building something from scratch, who's going to build it? Are we building it in-house, or is someone going to build it for us? And if someone is going to build it for us, who owns it at the end of the day? Will it be the corporation, or we are simply, it's going to be owned by someone else? Are we going to have distributed ownership? Is this something going to be partly owned by us or by those building it for us? Where does the responsibility come in? Who owns what? Who is responsible for what in this sense? Yeah. And already some of these things we're talking about, they're not new. Most of us are in an IT setting, so we know what we're talking about. What is partly owned by us and what is partly owned by somebody else. I was recently telling somebody about, we're talking about our mobile networks, the current mobile networks. Me who lives in the rural setting, network connection is something that is always on our minds. Why? Because if you're in a certain part of the house, you don't have network. It's very unlike those of you who are in urban areas, where anywhere you are, someone will always reach you. And we were talking about, I was explaining to someone about the mobile networks and those masts that we have. Actually, in actual sense, these are not owned by the mobile network providers, but by someone else who actually comes in to rent space, physical land, and then the mobile network providers come and rent space on that mast. So that's a typical example of distributed ownership and distributed responsibilities. Yeah. So in the IT setting, so it's the same thing. I think these are things that we think about when we are now thinking in terms of design, selection, and implementation. Who owns what and who's responsible for what? Yeah. When we come to the implementation part itself, this is the part that requires the design. And this is where you come in. Designing of the data architecture. What kind of data do you envision your system will hold? Will it need to be, is there a need for interoperability? Data format, is there a need to have a clear data format within your data architecture? Who has access to what, in what format, and so on and so forth. Then you have the communication architecture. Security measures, design structure, implementation principles, and delivery. So we're going to go through these bit by bit. Shall understand them within each for each section. The context of and background to ICT design and selection. This is where we are now going to talk about the concepts that we meet and what they mean, so that we have a clear understanding of what we are talking about for each. Things that we shall need to understand by the end of this section. One is system users. Who are the system users? And most likely also we shall discuss the issue of stakeholders. Who are the stakeholders? The impact on the system users in regard to the requirements. What impact would we expect with this new system that we may want to undertake? And when we are implementing new systems, we also, most of the time, ICT designers think about the new technologies that are there. So things like AI, um, things like cloud systems and so on and so forth. These are new things that come up and that may be part and parcel of these new systems. So your systems users will definitely be impacted by that, by this new system. Their ICT literacy levels, the age of your users, the workspace that you have, and so on and so forth. We need to understand the focus of IS and ICT systems. So these are definitely also the new technologies that come in. Logical modeling and physical modeling, these ones we shall discuss, especially in this session, and so on and so forth. These are going to be part and parcel. So we want to talk about system development and some of these concepts. What are systems, information systems, systems design, and systems development? So let's start with the most basic. And what are systems? What is a system? What would we define a system to be? What do you think it is? Any ideas? Any ideas what you think a system is?
Doctor, let me give a submission.
Yes, please.
My understanding of a system is that it's a tool that, let's say, an organization would use to carry out its operations.
Okay.
So it's a computerized tool that
Yes.
enables the organization to have an overview
Yes, please.
of its operations and enter data, do data entry and storage.
Okay. Thank you, Teresa. I think I think with a minute we think of systems, that's the first image that comes to mind. Anyone else?
Well, Doctor, maybe I can also give my submission.
Yes, Winfred.
Me, I look at a system as a combination of components, different components working together to achieve a certain goal, designed to achieve a specific goal.
Yes, Winfred. Thank you. So I think Teresa and Winfred have given us the precise definition of a system. Now, before I come to that definition, I was thinking of something. Most of the time when you hear people talk about systems thinking, especially the technocrats and those academics in the ICT field, it's usually used as a should I say a stick to punish where they find something is not working. So I went out and pulled some funny definitions. Why? Because it is important as we are doing these things, especially as we are becoming the technocrats. It's important to understand sometimes that we use this as a stick to hammer others. So here there were some funny definitions I got off the net. So one says a group of components working together to achieve a common purpose, or more likely a way to make sure the surroundings, everything else, are properly blamed for the failure. We have many times, and this is for us to be very, very careful. just to have a little bit of humility as we get into this professionalism. There is a thinking that as we are going into to now implement these new principles, everything is going to work perfectly, because this is the one silver bullet that will solve all the problems. No, not the case. This is not the case, because these things are being done by human beings. Okay? As much as we want these things to work, this is not always the case. And the systems, as Teresa and Winfred have given us, we find actually these systems everywhere. Yeah. So if we look at the definition, so we see the academic definition, we're looking at components that function together to achieve a desired result. Yeah. Components that function together to achieve a desired result. So one, as we're defining these things and understanding them, one is to understand the reality. In theory, we have the theory, and then we have the reality. For me, I'm an ICT professional, and I'm also a farmer by birth. That these have just fallen into being a farmer by virtue of being my father's daughter. So I've become a farmer. You know, when you're a farmer, there's nothing that brings reality down to earth like being a farmer. Especially now when you're a commercial farmer, they will tell you all these things. If you do this, you will. If you now start planting coffee, you will make so much money. Then you plant the coffee and coffee prices collapse. If you plant sugarcane, you will become a billionaire. You plant the sugarcane and the sugarcane catches fire. So, and it's all actually a system. It's actually, if you look at it, it's actually a system. Components are working together. You have the land, you have the soil, you get your inputs, you get your whatever it is that is coming, you plant. The rains come, they may come, they may not, they may come at different times, and then the sun comes, and life happens, and the desired result doesn't come out as we wished. Okay. So the important thing of bringing out these other parts, these other the light look at the systems definition, is to remember that things don't always work as we would like. So we have these components that come together. We expect them to function together to give you the desired results. Okay. So these systems, as we say, can be physical, biological, or social. So the physical systems are those based on the natural physical laws and ignore questions of values, motivations, and preferences. So the physical systems, we can talk about our ICT systems. Then you have the biological systems like your respiratory system, your digestive system. Then you have the social systems that deal with interacting with people. Okay, so this is typically systems. Then you have what we call systems thinking, focusing on how and why systems behave the way they behave, the relationships that different parts will have. So these are systems. So we come to what is an information system. Okay, so just as we defined the components, you have an information system will have the hardware, okay, to have the software, to have the data, the people, and the processes. So these parts are supposed to work together to give us a certain desired result. And as we know, sometimes the hardware may fail us, the software may fail us, the data may fail us, the people or the processes. On a good day, we would like all these things to work together perfectly. And sometimes they do, sometimes they don't. Okay? But all of these are components that are supposed to work together. So the objective of this module is to see how best we can get all these components to work together, how best we can we can carry out the design process, how best we can carry out the design process so that we can get something close to the desired result. Okay, again, I gave you the example of farming to say things don't always work as we would wish them to work. Okay, but we would like to get the best possible result. So the question is then, what is a system design? What is the system design? So the system design is a problem-based solving situation where we look at the problem and we try to figure out a solution to the problem. You're looking at, you have a current system, the way things are being done now, and we're saying what is the problem with it and how can we then find a solution that gives us that best possible desired result. That is what system design is. So in this process, we define the architecture, the components, the modules and interfaces and data for the system to satisfy the specified requirements. So we define all of these, and then we say our system should be able to handle this kind of data, should be able to have this kind of interfaces, should have these components and modules, and this kind of architecture. Yeah. So it is seen as the application of systems theory to product development. So that would be the system design. So then what is system development vis-a-vis system design? What is system development? And system development, we all know what that is. We've heard about it from our undergraduate degrees. So these are the activities, the best methods, the activities, the methods, the best practices, and deliverables. Yeah. That will help us get our system, develop our system. So here we are defining, designing, testing, implementing our new system. So there is the design part, then there is the development part. Okay? So this could be the internal development of a customized system, or it could be the acquisition. It could be the internal development of our customized system, or the acquisition. So here, just to make it very, very clear, we are not necessarily referring to us now developing systems as we did at undergraduate level, that process we went through. But it could be, yes, development of one internally, or it could be development one from a third party, or acquisition of one that is currently existing, or maybe tweaked here and there for our sake. But the entire system development life cycle that we learned, that those principles that we picked up, those methods that we picked up while we're carrying out our undergraduate degree, those principles still hold fast. We still maintain those as is. So we have the system development and program development. Those are not the same thing. So what we mostly did at undergraduate level was program development, where we were hands-on developing programs. But in this case, when we talk about system development, we're looking at all the 5 components of an information system. Okay, we're looking at the hardware, the software, the data, the users, and so on and so forth. This is what we are looking at. Do we have any questions so far?
Yes, doctor.
Yes, please.
Good evening, doctor and the team. My name is Dennis Sida.
Yes, please, Dennis.
The first thing, I'm glad to meet my fellow farmer in this academic world. It's always rare to find farmers.
Yes, please.
Yeah, my question is, in the beginning, you said that we are looking at this in a holistic manner.
Yes, please.
But I'm trying to relate it in the environment where I come from, where I work. I work
Yes.
in a bank setup.
Mm-hmm.
Now, when you look at a system, subsystem, even before we start looking at the development and what have you, there is a lot behind. For example, from business case, from having RDs, having FSDs, having SRS.
Mm-hmm.
So are we plugging in at a higher level, or this is also part of the information we shall have to look at as we proceed? Thanks.
Yes, thank you so much, Dennis. I think that's a very good question. This is a plugin. What you are referring to is the even bigger picture would be the enterprise architecture. Some of you, I think that the group, the 2024 group, by now you have gone to enterprise architecture, and you've seen how holistic and wholesome it can be. So this part is simply a plugin into the entirety of enterprise architecture. It's simply a small section of it. Those who have done enterprise architecture, is there anything you can maybe add on? Hello?
Doctor, we are following.
Yes, please. I was just asking for an input. So if you look at enterprise architecture, it's more holistic because with it is talking about the business architecture, information, application, technology, so on and so forth. And then the design part is aligning those organizational business strategies. So it would be a one plugin or one element that is plugged into enterprise architecture to give it that more holistic approach. Now, specifically for ICT design, where we are still with the same perspective as enterprise architecture, as all these other as ICT strategies and so on and so forth. It's still within the same alignment. It's we are now looking at it in alignment to all these other modules that you are taking at the holistic sense. So we are moving away, Dennis, we're moving away from the skills that we picked up at undergraduate level, and we're now looking at design at a management level. I don't know if I'm making sense.
Yeah, doctor, I'm aligned. Thanks.
Okay, thank you. So what are the risks with systems development? What are the risks with systems development? One is that many systems are rarely finished. Most of the time, they are rarely finished. And I think one is maybe the hype that may come with it, the hype that we may think this is going to be the silver bullet that solves everything, and in reality, that's not the case. And because of that hype, they come also with exaggerated budgets which cannot be fulfilled by the organization, or even they're even competing priorities within the organization. Because also of the same hype, usually the goals are not cannot be accomplished. These goals cannot be accomplished. So this is one of the things, is always approach this with humility. What can be done and what cannot be done, the reality of the context, what we are currently living with, what is possible and what cannot be possible. There may be difficulty in determining the requirements of the system. Sometimes our users may want things that are beyond what is possible. Sometimes also we ourselves, the ICT side, we may oversell ourselves what is possible and what is not possible. Then we have the ever-changing requirements. Even as the system is developing, someone is talking to one of your stakeholders, may talk to somebody and they sell them an idea that is unachievable, and these ever-changing requirements also keep changing our budgets and scheduling and so on and so forth. Then also the rapid change in technology. At one point you're working with 4G, the next time you're working with 5G, and so on and so forth. Okay? So these ever-changing technologies. So what is systems analysis? Because when it comes to systems development, it goes hand in hand with systems analysis. So this is the problem-solving part of it. When we are determining what is it we need to do, what is it that is needed by the organization, by our stakeholders. Yeah. We are trying to create the components or to define the components of our system. So when we are defining our system, or we are doing systems analysis, we focus on the areas we focus on are the knowledge, the raw material used to create the useful information, the processes, the communication networks, and who the stakeholders are. Yes, Dennis, you have a question before we move further, or comment?
Yes, Doctor, thank you. I wanted to speak to your previous slide.
Yes.
Maybe if we just go back a little bit. Where we are saying that many system development projects are never finished. Mm-hmm. And then we say that if they are finished, some are 200 or 300% over budget. Mm-hmm. But Doctor, I was thinking that if you look at these projects, the aim is to, like at the end of it all, to have benefit realization. Mm-hmm. So if we are saying most of them are never finished, so are we trying to say that in most of the projects there is no benefit at the end of it all? Thanks.
No, thank you, Dennis. Thank you, Dennis, for that question. I think this particular slide was talking about what are the difficulties. What are the difficulties? Is it that all these projects don't work, systems projects do not work? No, that's not necessarily the case. We have a number of systems that are here and they are working, but usually you find, maybe I would say, the intentional ones simply don't work. I'll give you an example. I'll give you an example of a system that worked for UMU, and that worked for UMU immediately it was implemented. That was the e-learning system. It was implemented and it worked. And this was Moodle. And if you look at the cost of Moodle, it was simply the hardware, I would say, and the interface that was a nice user-friendly interface that was implemented. And that was it. I remember before Moodle, there was an attempt by an organization, I think it was based in India. This organization, I forget the name. At that time, I was head ICT. At that time, the providers, the service providers of this system came to UMU to sell this system that was, quite frankly, really future head. It's a mature system and well designed. And they came and presented it to management, and everyone was sold on it. It looked like a very good idea. And after that presentation, nothing happened. I remember when we were first trying to implement, we were thinking of selling Moodle. I remember there was a group of ICT professionals that came from, actually, I remember Centenary Bank. And their argument was, they were actually stating to the ICT department, to the management, that UMU really needed a fully fledged system, not Moodle, that was paid for. And I remember posing to management the question that you actually, as management, received a visitor. It wasn't even ICT that brought, it was one of the management members. I said, how far did that go? And they all said no, they didn't implement it. But when COVID hit and the idea of the reality of online learning came in, we implemented Moodle within a heartbeat. No one even wasted time. We implemented, it was freely available. It was something that was well understood by everyone, by the ICT department, by Renew, our provider, and several people were using it, and within a heartbeat it was implemented, and it's, to this day, it's still being used. So those particular programs, those projects that do fail, is when something is over budget. And probably at that time, when UMU had options, that time we had physical classes and everyone was thinking, what's the point of spending this amount? But when reality came, this thing was picked up immediately. So it isn't, Dennis, that all of them do fail. Some do fail, some do, especially those which come with a lot of expectations. They do fail. Yes, Winfred, you have something to comment, then we go back to Dennis, because your hand is still up.
Thank you, Doctor. Mine is just I felt I needed to say something about it because I'm one person who has a lot of interest in enterprise architecture.
Yes, please.
And I'm closely following. Just like Dennis brought it out and he was wondering. Now I also happened to be wondering with the same things, because every time when you come to read such things, that when you look at the technology, the technology transition that we are heading on, you realize that most of the initiatives that are brought, most of them collapse. They don't hit the objectives.
Mm-hmm.
But then, because it is a mass, it is like it's big. You may not see it if you are not very critical, and if you're not following up exactly what is happening. Now, I research, and this research is also on digitalization. It is almost similar to the same thing we are talking about here, project failures.
Yes.
Digitalization has a lot of benefits. There are so many benefits. And when you look at those high income countries, you realize that for them, they have even tangible benefits that really they show. But when you look at the middle and the low middle income countries, you realize that for us, we are always failing. We look like we are moving, but the truth is the projects are never reaching the targets. Factors are not only technical. Here, I can only see we are only looking at the technical aspects of it. But there are so many that contribute to the failure of most of these initiatives.
Yes.
And you realize that in the long run, much as we are embracing digitalization, but we are failing to manage it. There is failure to manage the systems, failure to manage initiatives, and this could be as a result of either there is no clear plan, there is no proper administration, the governance. There are so many factors. That's why I think that's why you were overemphasizing the issue of enterprise architecture.
Yes.
Because with enterprise, you get a whole grip of what exactly the whole thing is. That it's a combination of many factors. It's not just a one thing show that because the technical bit is handled, so the humans can be left. If you do the change management very well, then it can also cost you a downfall. Something small can cause a system, a very good system. Poor stakeholder management can cause a very good system to collapse in a blink of an eye. So that is my submission.
Thank you so much, Winfred. I think that is it. Actually, you are preempting some of the things, some of the sessions that we are going to have. Poor stakeholder management, and actually the stakeholders are the people who will fail it if they are not managed well. That is a key point. So if we come back to the slide of system analysis, the areas that we focus on, the knowledge, the information used to the raw material, or in other words, from the raw materials that you'll get, what information do we expect to get out of it? And how best can we do this? What can do this for us? The processes or the activities that need to be carried out in the business processes, or in the everyday business. What are the activities that are carried out that generate this raw information, or that turn it into something useful? Communication, how the system interfaces with its users and other systems. Then the stakeholders. So this is where Winfred's point is really key. Is so important. The stakeholders. These others may be easily defined. Because they are physical. Should I say they are physical? But when you come to stakeholders, the people, the human beings are the complex part, I would say. They are the complex part. We don't behave the way we are expected to behave. We don't react the way we expected to react. Then we have our skills, we have our do's and don'ts, and so on and so forth. So these are a key part. And if they are not well managed, can very easily fail a system. Very, very easily. So who are the stakeholder? Who is the stakeholder? In the context of the information system or the system. So it is that person who has any interest in the existing or proposed system, that person who has an interest. Okay? So this person could be the one who's going to operate the system, who's going to enter data. It could be management. It could be even the provider, the service provider. Okay? So the service, this could be the owners, the internal system users, and external system users. Who is this person that has an interest in this system? And these come, and this whoever has an interest can decide to make or break this system, can decide not to use the system completely, okay, or can decide to campaign for it or decampaign for it. So the owner could be the system owner or the system advocate. So it's the person who is responsible for funding the project. And the impact of this person is extremely important. So here is a question. We, as UMU students, you're all using Zivasti. So who is the owner? Who is it that advocates for it? Of course, you have the developer, the one who provides the service. But then at the university itself, who is the person who advocates for it? Is it finance? Is it management? Is it the students? Who is it? Who has a stake in it? Yeah. Then you have the internal system user, the person who is responsible for carrying out the processes and procedures. So the employee who is responsible for generating, the students, the users, the internal users. Let's say if you look at Zivasti, you have the internal system user is the student, it's the faculty administrator, it's the lecturer, it's the finance person, it's registry, the members of registry. All of these are internal system users. Then you have the external system user, those who are outside the network. So it could be the service provider who's using this system. For Zivasti, you could even have the bank. The bank is also an external system user. So this could be defined even based on this list that you see here. So these are our stakeholders. And again, we said this could make or break your system. The system life cycle versus the methodology. So we have the system life cycle, then we have the system development methodology. These we have seen before.
Oh, okay. I have some time.
Okay, that one is, sorry for that disruption. So the system life cycle here, what is it? It's basically the beginning of the system to its end life, to its point when its life ends within the organization. This is quite different from the system development method, which is the formalized approach to developing a system. The approach, as we're developing the system, by developing the system, I mean, if I'm a system developer, I sit down with the users, I discuss requirements, I sit down, I develop it, I code it and test it and so on and so forth until it is implemented. That is the system development process. The life cycle is from the time it is developed, implemented, matured, and then comes to its end when it's no longer needed within the organization. So here we have the system development life cycle, of which the system development process is part and parcel of the system life cycle. Okay? It's part and parcel of the system life cycle. The life cycle itself comes to obsolescence when it's no longer necessary, when it will come to its end and a new system is developed to take over. So the system life cycle includes the system's operations and maintenance until it comes to maturity, and then eventually its use is no longer necessary within the organization. So we have several different development processes, system development processes, and this, if we remember them from our undergraduate level, you have the system development life cycle, the prototyping, rapid application, rational unified process. These are simply the methodologies that are used, that can be used to develop a system, a new system that is within an organization. So any of them can be used depending on the most appropriate approach, and you can, within your time, just go back and read through and revise, remind yourself of these different development processes. Why is it necessary to use a consistent information system development process? One is solution. What is the solution? Is it the solution to your problem or the consistent problems that you have? If it fits the solution, then well and good, continue. But using also a consistent one creates efficiencies, because this is something you're familiar with. You don't have to go back and forth to try and learn something new. If this is something that the organization is familiar with, continue with it. Then it also helps produce consistent documentation, which documentation is important for maintenance. Then also promotes quality because you're using the same thing over and over again. Now, with system development life cycle, you have what we call problem-solving approach. Okay, the problem-solving approach is is part and parcel of the system development life cycle one. Then also with system development and also with the system development life cycle, or the design process, the design, selection, and implementation process. Yeah. So we study and understand the problem and its context and its impact. From this study, we define what the requirements are. What do we need to be able to create a solution or to meet our solution or our desired results? Yeah. So in understanding the problem, the context, and impact, we come up with our requirements. Now, from the requirements, we begin to identify possible candidates. What is it that will solve our problem? Yeah. You look at what is currently existing on the market. What are the technologies that we have? And can we get something off the shelf, or can we mix and match? Can we have a developer creating for us a solution? So you begin to identify what are the possible solutions. And from that, you design your solution. Okay? You design your solution and or implement your chosen solution. So after that, you observe and evaluate what you have implemented. Is it giving you the desired results that you are looking for? Now, in the design process, you have what we call our logical versus physical model. So the logical model, you have a pictorial representation of what you want your system to be, what it should do. Then you have your physical model. This one gives you the technical picture. Okay? So the logical model is going to define your business requirements and functional requirements. The physical model gives you the technical requirements. So the logical model is conceptual. it's a conceptual system about what it is that you expect. The physical model is what you will implement. So of course, these two are highly related because the technical will tell you whether it can achieve your business requirements and your functional requirements. But if I implement it, will it be able to fulfill my business requirements and functional requirements? So the system development process has these stages. You have the system initiation. And in the system initiation, this is where we identify our problem. Okay, coming back to our problem-solving approach, where we understand the problem, its context, and its impact. Okay. Then you come to the system analysis. So in analysis, we understand the problem and identify our candidate solutions, requirements and expectations. Then you have the system design. So the system design, it could carry both the logical model and the physical model. So based on your analysis and identify the expectations and requirements, you develop both the logical model, then the physical model. So these should be able to give you, after the end of it all your possible candidates. Then when it comes to implementation, you implement your chosen solution, evaluate, and if the problem still exists, you go back to the drawing board. You see, where can we find something completely new? Can we tweak it to make it more efficient, and so on and so forth. Now, based on these steps, these are the possible project phases that you will have. And all of these are not new. We are simply revising some of these, but in terms of ICT design selection. So in the initial stages of problem identification and then analysis, you have the first two stages of scope and definition. So this is the initiation part. The analysis part is when you come up with the requirements, the logical design. Okay, this is where you have the systems analysis. Then in the system design part, which is in reality on continuous, this is where you have your system design. Then you come to the physical design, which is part of the design process. Then the construction and testing. Then finally, implementation or installation and delivery. So just to repeat ourselves, the scope definition is the initiation and problem identification part. So in this phase, you would have identified your sub-phases, the tasks that need to be done, resources, budget, and scheduling. In the analysis part, requirements analysis, here you determine the user expectations for the new system or modified system. Project requirements are normally driven by business requirements. Then you have these several questions that need to be answered. Capabilities, what capabilities should the new system provide? The data that must be captured, performance, priorities. So in this phase, you also identify your internal and external stakeholders. And this is the time you identify them and then engage them as much as possible. So after the requirements analysis, this is when you come up with your logical design. This is, remember, the pictorial model that you'd expect, this is where you come up with that. So after the logical design, you come to the decision analysis. So here, the logical design would help you identify your candidates, the possible candidates, candidate solutions or systems. So that these it would have provided you with a technical feasibility. What technologies are we going to use? What technologies are available to us? Then operational feasibilities, will the solution fulfill the user requirements? Economic, in terms of budget, what is cost effective for us? Schedule, can the solution be designed and implemented within an acceptable time? Then risk feasibility, what is the possibility of a successful implementation using the technologies that are available? And so this is where you pick your possible candidates. Then you have your physical design and integration. So once you've selected the most appropriate, you now translate that into business user requirements, into the business user requirements that you would have identified in your logical, you now translate it into a system model. Now, you have two extreme philosophies for physical design. You have design by specification and then design by prototyping. So design by specification, you have the physical systems detailed specifications that they are produced, which may be produced into a blueprint. Then you have the other one, which is prototyping, where you do something incomplete but functional and begin to test it out with users. So depending on which you may choose, either one of them, depending on what you have available to you, you can pick any of those to come up with your physical design. So once this is done, you go to construction and testing. So this one, you go through the actual development, you install it, you test it. There could be lab testing with users. So this is where you, again, the development part, we don't necessarily mean that it's developed in-house or developed. It could be something you have purchased or something that is custom built for you. You have your database, you have your users and interfaces, the hardware and the network. You actually test with what you have available with you to see if it works or not. So once construction and testing is done, this is when we come to installation and delivery. Where you have the fully fledged system which is now delivered and it is in production. You go through user training. Then you also have completed documentation for codes and for users. Then convert existing data into the system. So after these are done, you come to system support. So once the system is implemented, you then now come to system support. This is, and here choices must be made. It must also be clearly agreed upon. If you've purchased something, if you have a purchased system, what is the kind of support you have available to you in case something collapses? If it is purchased, if there's a third party, as it is a service provider the service provider that is ongoing, then the system support there may be clear at that point. But also still you have other things like in case your provider is far away. Now take the example of Zivasti. Zivasti is clearly owned by a third party. But then there are situations where the user may need support and the owners of Zivasti are not physically available. who then provides support, and to what extent could they provide that support. So all of those should have been part and parcel of the design process. Okay? So it's not an afterthought, it is something that should have been part of the design process. So all that we've been discussing is actually represented in this ICT project phase. The entire thing of what we've been discussing. You have your current system here, which may or may be operational, which may or may not be working for you. So based on the analysis with the current users, you determine the current scope of things. What is happening and what needs to be changed. This is where the problem analysis comes in. So with the scope of definition of what is currently happening together with the current stakeholders, you define the problem through problem analysis. And from that problem analysis, you determine the requirements of what needs to be changed. From that, you come up with your logical design. The logical design leads you to a decision analysis where you select the candidates of the current candidates of systems that are available, which then leads to your physical design. The physical design comes up with a prototype, which is constructed and then tested. Once that is completed, you come up with a complete system which is installed and delivered. So this implemented system then goes through its life cycle, which comes back to an operational system which may at some point become obsolete. And then we go through the life cycle one more time. So everything we've been discussing so far is summarized in this image of the ICT project phases. Do we have any questions so far? Yes, Winfred.
Well, thank you, Doctor, for the good presentation. However, my question is, in all of this that we have been discussing,
yes,
I'm just trying to wonder. I'm not really seeing the element of enterprise architecture as it is. So how do you incorporate it in here? Because this is still, I am still looking at it as plain knowledge of what we have always had, general knowledge of systems. But then, now there is a now you see when it comes to the gap that is being created out of when you look at ambition and achievement. Ambition is there, and then as you keep achieving, the gap gets that gap gets wider and wider. That's what I see in these things of technology. So I'm wondering, how is the enterprise architecture part of it catered for in this thing?
Catered for in this. I think, Winfred, this will get clearer as we go along the way. Let me give you an example. We've done, each one of you has done ICT strategy.
Yes, we did, Doctor.
Yes, we did. All of you have done ICT strategy.
Yes, we have.
Now, when we think about ICT strategy, where would this fit in? Can we think of where would this fit in? Let's think about it. With ICT strategy, you're basically starting with where are we now and where do we want to be? You're looking at ICT, the entire organizational ICT holistically. Where are we now and where do we wish to be? Okay? So now, when you think about this, when you think about this is one of the ways ICT strategy would be implemented. This is one of the ways it would be implemented, the practical ways the ICT strategy would be implemented. Now think about enterprise architecture, which is looking at realignment. Realignment. In the process of realignment, this is where you may look at your current system and how it may or may not align with the current business process or the ICT mission and vision. This current system has become absolute, and it is not, it currently isn't. It may have been identified during the formulation of the ICT strategy or during the realignment process. Winfred, I don't know if I answer your question.
Yes, doctor, I'm trying to connect it.
Yeah. So this part, the problematic part, may have been identified during that time. Yeah. This would have been the time, the system itself, this would have been the time it may have been identified. So it is a component of, would I say, the two ICT processes. I don't know if I'm making sense.
Yes, doctor, you are.
Okay, thank you. So here we come to the phases of the system development life cycle, which have actually been, it's a summary of what we've discussed already. The problem identification, the project identification and selection phase. So this would have been the time when we analyze our current situation, we scope out, we do a scope definition, problem identification and analysis. This would be the phase, together with initiation and planning. Then you have the requirements analysis, the design, construction, acceptance by users, and maintenance. So where does project management fit in SDLC? Practically about 90% of it, 90% of it fits in project management, according to this diagram. So what is a project? What is project management and project process management? Because this is all part and parcel. When we talk about ICT design, it's part and parcel of the project management process. So a project is simply the sequence of events connected that are joined together to help us achieve a certain goal. So when you have a project, you have a goal that needs to be attained. And that project will have several activities set up, and these activities are connected. And the objective, the purpose is that for these, once we fulfill each of these activities, we'll have attained a certain objective or purpose. The management part is simply planning, connecting, controlling, directing, and so on and so forth, all these activities in order that we attain our goal. The process management is when you document and continuously manage the processes, the different aspects of your project. Now, the objective of every project is to achieve success. That is what we want. Remember, we talked at the beginning, we talked about the risks and difficulties with system implementation. And one of the things we said was a number of projects end up being incomplete. Yeah, a number of projects end up being incomplete. One of the worst things we don't want, the things we don't want to do is to bite off more than we can chew. Yeah. So one is to have acceptance from your customer or your stakeholders. What you need is acceptance from your customers or your stakeholders. If you don't have acceptance from your stakeholders, then this project will not succeed. Time management, to ensure that every milestone you expect to hit, you hit it and within time. Keep your costs minimal. Yeah? Keep your costs minimal. I think this is where one of the things agriculture very much relates to these projects. Time management, ensuring you acceptable customer, you must have a market, someone who's going to receive your good, whatever it is you're planting. Make sure you're planting on time. Then keep yourself minimal. It's one of the things I learned with agriculture. Get the cheapest inputs possible. Because anything, the markets change, weather changes, and so on and so forth. Keep your costs minimal. Finally, minimal impact on ongoing business operations. Yeah. So these are key points. Being as realistic as possible with your project. Be as realistic as possible. Okay, that's a key point. Expectation management, and this is going to be one of the things that is going to be key, because this is what handles or manages your stakeholders. The unexpected and gradual growth of requirements during a project. Your stakeholders may expect too much, or they may expect too little. Manage those expectations. And these unexpected growth of requirements can lead to uncontrolled addition of technical features, which may eventually fail your project. So be as realistic as possible. Try to be as realistic as possible. So the project management functions include scoping, planning, estimating, scheduling, organizing, and directing. Yeah. Scoping, planning, estimating, scheduling, organizing, and directing. When we actually go through this, the management process, we'll unpack all of these. Now, before we get too far into it, I've already given you an assignment, which is going to be submitted. I'll give you a week. It's an individual assignment. This is going to help us look at theories, especially system implementation and adoption theories. These theories help us to see what the academic world has identified as the key success factors to implementation and adoption. So your first assignment is to go through these theories. So you're going to start by reading and writing about 10 common mistakes that IT departments make in the process of developing information systems. For each problem identified, propose a solution. Then look at these theories. These IS implementation and adoption theories. Research and write about each of them. So these will be the first things that will introduce you to what the academic world has identified as the critical success factors as far as implementation and adoption is concerned. They are the things that one must think about as one is carrying out the design and selection process, on whether something is going to be adopted or not, on whether your project will be successful or not. Do we have any questions so far? If we have no question, I think we can end our lecture there. And I just want to point out, in the WhatsApp group, I sent you the link on Moodle, where this module has been activated in Moodle, as well as the enrollment key. So once you're in there, you'll find the current lecture slides. I'm also going to pass this on to ICT, and then I'll upload the video up onto Moodle, hopefully before Friday. Hopefully before Friday. Is that okay?
Yes, Doctor.
Doctor.
Yes, Doctor.